What's up guys, welcome back to the channel. In this particular video I will explain the problem number of subarrays with maximum values in given range. Solving this problem is really fun guys, so I want you to stay tuned till the end of the video. Starting with the problem statement, so it basically says that you are given an array of n elements and L and R. So we are basically given an array and two values L and R. Our task is to print the number of subarrays such that the value of maximum array element in that particular subarray is at least L and at most R. Okay, let me explain this. So first of all guys, we are given a range which is from L to R, right? So you can think of this as left and this of right. So this is a range which is given to us, and we are also given an array, and our task is to count the number of subarrays which have the maximum element in this range. Well, we have one example here, so let me explain with the example so that it gets more clear. We are given this particular subarray and the value of L is 1 and R is 10. So we have to count all the subarrays which contains the maximum element in the range from 1 to 10, right? And this is an inclusive range, so we are going to include L and R as well, right? So for this particular subarray, you can see that we have got one subarray which is 2 comma 0. For this subarray, what is the maximum element? Maximum element is going to be 2, and you can see that 2 lies in this particular range. So 2 comma 0 is one valid subarray. So like this, let me write all the possibilities. So first of all, let me erase this, and here uh, the first possibility that I can say is 2 comma 0 itself. After this, the second possibility can be 2 itself. So this is again a subarray which contains the maximum element as 2, and you can see that 2 lies in this particular range. After this, we cannot include 11 guys, because 11 is something which doesn't which is not a part of this particular range, right? It is more than 10, so we can include this 3. I can write a single element 3 here, and for this the maximum is going to be 3, and you can see that 3 is in this range. After this, we have got one more subarray which is 3 comma 0, and you can see that for 3 comma 0 again the maximum is 3, and 3 is in this particular range. So there are four possibilities guys, there are four subarrays which have the maximum element in this particular range from L to R. So the answer is going to be 4 for this particular example. Now guys, I hope you have understood the problem well, so let's talk about the solution now. Okay, so guys, I have written the same example as given in the problem statement. And after looking at the problems, the first approach that will come to your mind is you can try out every particular subarray of this array. And then for those subarray, you can find the maximum element, and then you can check if the maximum element lies in this particular range, right? So you can write something if my max element is something which is greater than equal to L, and max is something which is smaller than equal to R. So this is something that you can do, and then you can simply write uh, count plus plus, right? This is what you can do. But I'm more interested in some like the optimal and challenging approaches. So let me start with the optimal approach, guys. First of all, I will explain the intuition, and then I will talk about the approach. So see, we are given this particular range. So first of all, let me draw the number line. So the number line basically start from 0, then somewhere I will have a point L. Just forget about this particular range like 1 to 10. I'm writing L anywhere in the middle, right? After this, I will have some right point which is R. So the range is going to be this one, right? We have to find all the subarrays, or count all the subarrays which have maximum in this particular range. See guys, what we can do is what I can am thinking of finding the maximum element in this particular range from 0 to R, right? This is more easier than finding the maximum element in this range. After this, I can find the subarrays which have maximum element in this particular range, and then I can simply subtract 1 from 2. What I'm saying is, let me explain this guys. So this is nothing but smaller than or equal to R, right? So I will write the this particular thing is maximum element. Max element max element is at most, or instead of writing at most, I should write less than or equal to R. This is the first thing. And the second thing is this particular thing. What is this? This range basically is max element max element uh, is less than L, right? So once I have done this, I can simply subtract this particular value from this value. Once I have done this, I have got my answer. I hope guys this particular intuition is clear to you. And if you ask me why I am doing is this particular way, so the reason is, see, when I find when I perform this particular task, so you can see that this task is something which is independent of L, right? L doesn't have any role to play in this particular task. Similarly, if I perform the second task, so this particular task is something which is independent of R, so we are reducing the number of variables that we are going to have. uh, Let me explain the first task in detail, guys. So what we can do is, first of all, let me write count count subarrays count subarrays less than L, right? Okay, I don't have to write less than, I have to write with maximum less than. So let me erase this and I will write count subarrays with max less than L, right? This is what we are going to do, guys. How we can do this? Let me write the same array again. So I have 2 comma 0 comma 11, and then we have 3 comma 0, right? So let me write 3 and 0. So this is the array that we are going to take in order to understand this particular thing. What I can do is I can basically start from this point, right? So I will run a loop and I will iterate over each element. First I'm at this point and you can see that this element is something which is smaller than L, right? So this element can give me one of the subarrays which is going to have max less than L. So if my array of I if my array of I is smaller than L, in that particular case I will say that this element can be a part of subarrays, right? So my count is going to increase. uh, for now I am not going to write the factor by which count is going to increase, but you should know one thing, that count is going to increase if we have got element which is less than L, right? And if it is not, let's say we don't have 2 here, we have 13 here. So you can see that this cannot be a part, right? This cannot be a part. So we are not going to cover that particular case now, for now at least. So now I will come to this point and you can see that again I have got one element. Again I have got one element which is something which is smaller than L, right? Which is smaller than L. So this is again going to be a part of the subarray. So now again count is going to increase and you can see that this 0 can can be alone, like alone this can form a subarray, and this 0 can also combine with this 2, right? So we can have one more subarray which is 2 comma 0. Similarly, if we have element 1 here instead of this 11, so this 1 can combine with these two elements, right? So you can see that every current element, if this condition is true, like if the current element is smaller than L, then it can combine with all the previous element in order to form a subarray. So I'll write I minus, let's say we have one starting index here. So if this is my current I, so this is going to be my J, right? Even let me change the color so that it gets more clear, guys. uh, First of all, let me erase this, and now this is going to be my I and this is going to be my J, right? I have a range here. So from I to J I can include every element, so I will write I minus J, right? So this is what I can write, or I guess I should write, okay, I will write I minus J because this is index 2 and this is index 0, and you can see that 2 minus 0 is 2. So this one can combine with these two elements, and it can also stay as a single element, this one. So I will write I minus J plus 1. This is what I will do, guys, right? And what about else case? So now we can talk about the else case. We don't have one here, we don't have one, so let me write the original element that we have here, which is 11, right? And now my I is at this particular point. So you can see that we cannot include this element. And if I come here and I found my 3 is less than L, right? Let's suppose my 3 is less than L. So you can see that this 3 can stand alone, and uh, can this 3 combine with these elements? No, because we have 11 in the middle, right? So in this particular case, like when we have this case, so my J will increase and now J will become this element, right? Now my range will change. So you can see that if my I is here and I have greater element, so now J will no more there and J will come at this particular point, right? So that when I comes here and I have found smaller element, I know, guys, the value of L is 1, but I'm just supposing that this 3 is something which is less than L, right? So for that particular case, you can see that I can include this 3. So this is going to be a case I minus J, which is going to give me 0 plus 1. So I'm still going to have one element. So for else case, guys, I will write J equals to I plus 1. very important thing to understand, and I have to do this particular task in loop, right? So we are going to have a loop for I equals to 0, then I smaller than n, then I plus plus. And after this, guys, we are going to have a variable count as well. So count is something which is initially equal to 0. And this is going to be a long type, right? And after this, I just need to return count. Return count, right? This is the first step that we are doing, guys. This is the first task, like how I can find uh, how I can count all the sub arrays which have maximum element less than L. Now the second task is how I can count all the sub arrays which have maximum element less than equal to R. So for this, guys, I just need to do one modification in this particular function. I will simply write equal here as well, right? And both function are very similar. You can see that we are finding less than, but the only difference is here we are including equal as well. So this is the only change that we need to do. Once you have done this, guys, your task is done. This is all you need to do, and at last you can simply do this thing, and then you can let's say this value is less than less than equal R, right? And this value is less than L. So now you can simply return now you can simply return uh, less than equal R minus less than L, right? This is all you need to do, guys. Now let me show you the code, and from the code I will explain this approach in detail, right? So let me show you the code now. I have the code here, and you can first of all let me start with the Python code. And guys, I want you to understand every particular code explanation, because I am doing some modifications as well with every particular code, right? So you can see that this is the first approach that we have. First, I have like here you can see that I'm finding less than L, and after this I'm finding less than equal R, and you can see that both are similar tasks. The only difference is I'm writing equal here, right? After this I'm simply returning this particular value. So this is the Python code that we have. And now I want you to notice one thing, guys. You can okay, this is the Python code, guys. This is the Python code. After this I will come to Java code, and in the Java code I have done some modifications. See, I have divided this particular task into some functions. Now I am calling function instead of doing these tasks in the same function. So you can see that I have got this function which is less than equal to R, and this is less than L. And one interesting thing is the main function. This is the main function. This function is something dependent on L and R both, right? And I have divided this function into some subtasks which are only depending on a single variable. I have only L here, and I have only R in this particular function. So this is the Java code that we have. After this, in C++ code, I have again done some modification, and you can see that now I have a single function, because you can notice one thing, both function are doing a similar task. The only difference is of this equal, right? So now I have this function which is get count, and I'm calling the same function two times, right? And you can see that first we have value false, then we have value true. This value is basically going to tell me whether I have to include equal case or not. You can see that this is the equal case, right? This is the equal case. So if this is true, then I will include the equal case. You can see that I have X here and I'm checking equal to X. And if this is not true, then I will do this particular task. So this is how we can solve the problem, guys. Now for a single problem, there are multiple solutions. I want to try out every particular approach so that it basically improve your critical thinking skills. So this is all from my side. I hope you will like the explanation. Thank you.